In this video, I'm going to talk about general angles for trig functions or trigonometric functions. So let's start off with something like sine of theta, okay? Sine of theta. Now, what I'm going to do, I'm going to go ahead and make the simple assumption that theta is between 0 and 90, just to keep things simple. So you could have sine of theta. Instead of theta, you could have 2n pi plus or minus theta. So let's start with plus theta, where n is an integer. N is an integer. Now, please do keep in mind that n could be positive integer or negative integer, any of this. So if n is positive, what you're going to do, you're going to move counterclockwise, okay? So theta is between 0 and 90, so we are just restricting theta to that value to keep things simple. You always start off on the positive x-axis, okay? So positive x-axis here. So if you move, let's say n is 1, okay? N is 1, you're going to have 2 pi. And also here we are considering radians, not degrees anymore, okay? So if n is 1, 2 pi, so 1 pi is going to take you here, and 2 pi's are going to take you here. So it's a complete 360 degrees or 2 pi. So you're back here. Now theta is going to be right here. So it's going to be right there, theta. So that's your theta. So you're in the first quadrant. So this tells you that sine of 2n pi plus theta is actually just sine of theta. Simple. Now what if a sine of instead of 2n pi plus theta, I have something like this. Sine of 2n plus 1 times pi plus theta. What it does, it basically ensures that this is an odd integer. It could be positive or negative, right? Positive or negative. So in that case, what you will do, you'll just basically go odd numbers. So you start here. So let's say if n is 0, then it's going to be just pi, which is going to be right here. And then theta, you're going to move here. So you're in the third quadrant, and it's going to be negative. So what if n is let's say 1? In that case, you're going to have 3. So 2 times 1 plus 3. So it's going to be, 2 times 1 plus 1 is equal to 3. So it's going to be 3 pi, right? So 3 pi is going to give you 1 pi rotation, 2 pi's rotation, and 3 pi's rotation, and then theta right here. Do you see? So this, in essence, is going to be equal to just sine of theta, but minus. Why minus? Because it lands you in the third quadrant. What if now we consider for this one and this one negative integers? So let's say for sine of 2n pi plus theta, okay? But in my case, here n is going to be equal to negative 1. So then this becomes sine of negative 2 pi plus theta. All right? So now let's go ahead and start again. So you always start here in the positive x-axis. This time angle is negative 2 pi, not positive 2 pi. So instead of going counterclockwise, you're going to go clockwise. So you're going to go this way. So let's see. You're going to go this way. 1, 2 pi, right? So that's just negative 2 pi. But then plus theta, now you have to go back this way because it's positive. Negative means you're going to be going clockwise. Positive means you're going to be going counterclockwise. So this, by the way, is in the first quadrant. So this is going to be just sine of theta, as you can see. Now, let me go ahead and give you another example with negative numbers. So cosine of 2n plus 1 times pi plus theta. What is it going to be? Now, let's say my n is equal to negative 1. So it's going to be 2 times negative 1 plus 1 times pi, right? So which is going to be just negative 1. So negative 1 times pi is going to be negative pi, right? So this in essence is going to be cosine of negative pi plus theta, right? So if you again start here, let me go ahead and try to kind of draw something. So you're going to go counterclockwise. Why counterclockwise? Because this is negative pi. Then plus theta, which means you're going to have to go clockwise right here. And this is going to be your theta, okay? At this point, you have to realize that this is going to be in the second quadrant. But in the second quadrant, by the way, cosine is negative. So this is going to be equal to negative cosine of theta. And from theta, you can find the value, right? So remember, this is your theta in this case, this little one. And you can go ahead and find this value. And that's how it works. This idea I just described here, you can easily extend it to cosine of theta, okay? Generalization for cosine. And once you can do it for sine or cosine, then you can extend it to tangent and whatnot. However, let me talk about, let's use cosine as an example. Now, so let's say this is my cosine of n pi plus theta. Again, for simplicity, I'm assuming theta is positive between 0 and pi over 2. Pi over 2 is 90 degrees, or between 0 and 90 degrees. Now, if n is even, so that means let's say n is even, meaning n is equal to 2 times m, okay? Of course, n is an integer, n an integer. Okay, if n is even, or n is equal to 2 times m, where m is another integer, so in that case you will have something like this, cosine of 2m pi plus theta, and you can just go ahead and use this one. But if n is odd, then you can go ahead, I meant to say this one, you can go ahead and use this one. However, there are scenarios where we have a kind of interesting situation that arises. So let's say cosine of, instead of n pi, sometimes we have situations n pi over 2 plus theta. Now, if n is even, that means n is equal to 2m, this becomes nothing but cosine of 2m times pi over 2 plus theta. That, by the way, becomes cosine of theta. Cosine of 2 and 2 cancels, m pi plus theta. That is very easy to solve. You can go ahead and do it. But the problem arises when n n is odd, that means n is of the form 2m plus 1. In that case, what do you do? So let's say you have cosine of n pi over 2. So cosine of n pi over 2 plus theta. N is 2m plus 1. So we are going to write it as cosine of 2m plus 1 divided by 2 times pi plus theta. Okay, and if you simplify it, you're going to get cosine of m pi plus pi over 2 plus theta. So this is the one where you kind of have to think about it, where it is. So what is the ultimate sign of this trig function going to be? M pi, if m is even, then of course you're going to make a full circle, so nothing to worry. If m is odd, you're going to land here. And then you have to go another 90 degrees and then another theta, which will land you in the fourth quadrant. But if m is even, then you're going to be ending up here, right here, okay? And then pi over 2 is going to take you here, and then theta is, let's say, theta is going to take you right here, let's say. So you kind of have to do a little bit of analysis. Here, you kind of have to remember something that we talked about in another video. Let's say you have something like this at the end. After doing all the calculations, you end up with something like cosine of pi over 2 plus theta. So from here, you kind of have to go to sine of theta. Okay, sine of theta. Now, what is the sign of the sine going to be? Whether it's going to be positive or negative, it depends on where you ultimately land. If you land in the second quadrant, cosine is going to be negative, right? So if you land in the third quadrant, it's going to be negative. If you land in the fourth quadrant or the first quadrant, is going to be positive. So you just have to do the ultimate calculation where the theta lands. Of course, we did simplify this first, okay? It could either land you here along x-axis in the positive direction or along x-axis in the negative direction. And then you have to take this into consideration and figure out where it will be. So this is how, in general, you will deal with calculations of trig functions in terms of general angles. And if you understand one or two of them for sine or cosine, you can kind of generalize it to other things like tangent, cotangent, secant, and cosecant. I hope that this discussion was helpful. Thank you very much.